Hello, my name is Ken Vo. With me is Mason Godfrey and Thanh, and we'll be talking about exploiting machine learning with image manipulation. So the goal of our presentation is to discuss about the threats and machine learning models that has been trained to classify images. To start off, with the popularity of image classifier and machine learning itself, it has become a larger target for attackers, which generates a growing necessity to secure the integrity of its predictions. And the three types of image manipulation methods or attacks that we'll be talking about are the image scaling attack, the fast gradient sign method, and the one pixel attack. And when it comes down to all three of these attacks, its main focus is to fool the machine learning model to produce the wrong answer. Here's the first type of an image manipulation attack, known as the image scaling attack. As you can see on figure 1 at the bottom, it depicts the events that takes place. Here we have a source image of a teacup that is supposed to be fed into the image classifier. However, the attacker wants the image classifier to witness a cat instead, so the target image will be that of a cat. It is now that the smaller image of the cat will be hidden within the source image. This is done by altering the pixel value of the source image so that when the source image gets scaled, the cat image will appear in its place. We refer to this image as the attack image. If you look at the attack image A in the middle, it should not look any different from the source image of the teacup that it has derived from. And that is done to fool the victim, who happens to be the user of the image classifier. Now we have an image classifier model that makes predictions based on an image of a cat when its user believes the model is working on a picture of a teacup. Now we'll move on to the next slide.
Thank you, Kevin. Next, we're going to move on to the fast gradient sign method, where the principle of the attack is to create specialized inputs by introducing noise to the image. And although this does change the image from the original image, the changes are indistinguishable to the human eye. As we can see in the figure here, the output image looks very similar to the original input image. It's not quite the same, but if you're just looking at it, it's going to be difficult to see unless you're really zoomed in on specific pixels. However, this noise is still apparent enough where it can later confuse the neural network and result in a misclassification. Repeated misclassifications can grant the attacker complete control over the attacked model, and in the end, FGSM confuses the classification model by increasing the loss function. And this is done by modifying the gradients of the loss, which increases uncertainty. The third image manipulation method we're going to talk about is one-pixel attacks. One-pixel attacks reduce the ability of machine learning models to make predictions, while changing as few pixels as possible. So the main difference between this and FGSM is that now we're only looking at one pixel, but at the same time it's going to be just as effective in causing misclassifications to occur. It might also look like it's easier to detect. That's not always going to be the case. If we have a much larger image, then it's going to be a lot harder to spot the individual pixel. And this image here is only 32 by 32. One-pixel attacks usually use a machine learning algorithm in order to locate a single critical pixel that, when modified, will cause the misclassification to be as high as possible. So as you can see, there are a lot of different ways that attackers can compromise the integrity of machine learning models. Now I'm going to pass it over to Thanh so she can talk about the challenges a little bit more and then talk about some recommendations and ways to bypass these issues.
Thank you, Mason. Next, I will discuss some challenge and recommendation related to this attack. Regarding to the challenge, many libraries are prone to being affected by this attack. Implementing automatic controls to detect the image tampering is difficult. Related attacks have only a low risk of being detected, and attacks are often only need to change a few pixels. So some recommendations are to avoid using image scaling methods that look at only a few source pixels. Have a human look at the source and the input image before classifying the image. And use random selection to increase difficulty of attacks. And this is the reference for our presentation. Thank you for your listening.